Calculus is like the final boss in a video game. Everyone wants to get to that level, right? Well, one of the first main topics talked about in calculus is derivatives. But first, imagine you're walking up a hill. Now, as you're walking up, you notice that the steepness of the hill changes as you walk. You know how to calculate the average steepness of the hill, because that's just the slope. But how do you calculate the steepness of the hill of where you are standing right now? There's no way to calculate a slope for it because you're standing at only one point. That's what derivatives are used for. If we take a look at this graph, the average rate of change can simply be calculated by getting this point and finding the slope of it. Let's call the difference of the 2 points h. What happens if we move these 2 points closer together? What is the slope now? What if we move these 2 points right next to each other? Now, I know your pea-sized brain might not be able to comprehend that, but it's okay. America takes pre-calculus for a reason. The slope would be f of x plus h minus f of x over x plus h minus x. Since these points are also moving very close to each other, let's just pretend that they basically are the same points. We can use this by using limits. So the limit as h approaches 0 of this slope formula would be the instantaneous slope of the equation at this point. Let's look at a few examples. For this problem, all we have to do is substitute the function into the corresponding values. So it would be the limit as h approaches 0 of 3 minus 14t plus h minus 3 minus 14t over h. If we distributed it all out and combined matching terms, we would get negative 14h over h. Since h is approaching 0 but never reaches 0, we can cancel the two h's out because they would be the same value. Therefore, the derivative of 3 minus 14t is negative 14.
Nice.
This makes sense because the slope of the line is always negative 14, so the instantaneous slope at a certain point would still be 14. Let's look at a more complicated problem. Again, if we put this into the limit, we get this, and once simplified, we can cancel out the 4x squared and 9x. Then, divide each term by h and we get this. Finally, as h approaches 0, 4h also approaches 0, so we can cancel that out. And that leaves us with 8x minus 9. This is the equation for how to find the slope at a certain point. We will use f prime of x to represent this. Now the instantaneous slope at x equals 2 would be 7. There's actually a pattern here, and it's what we call the power rule. All you have to do in any given polynomial is just multiply the exponent by the coefficient and then subtract 1 to the exponent. So if we looked at the same problem, we would do that step and get 8z minus 9.
Boring!
Okay, so we're done now, right? Wrong. There are thousands of other rules about derivatives we need to know before we move on to integrals, so we're gonna speedrun them now. First, the easy ones. The slope of any constant is 0. E to the power of x is just e to the power of x.
Wow.
Any other base to the power of x is just that times the natural log of the base. Speaking of logs, the derivative of natural log of x is 1 over x, and if it's any other base, then it's just 1 over x times the natural log of that base. Moving on to trig.
Sine x just becomes cosine x, while cosine x becomes negative sine x. Tangent x becomes secant squared x, while cotangent becomes negative cosecant squared x. Do you see a pattern yet? Secant x becomes secant x times tangent x, and cosecant x becomes negative cosecant x times cotangent x.
And I'm too lazy to say all the inverse trig derivatives, so here you go. Moving on to more important stuff are the product and quotient rules. F of x times g of x becomes f prime of x times g of x plus g prime of x times f of x. Think about it like this. Boom, meh, boom, meh. Quotient rule is similar. Boom, meh, minus, boom, meh, all over g of x squared. That was basically it. Whoa. What if I have a function inside a function? Like e to the power of x squared. First, do everything normally, so it would just be e to the x squared. Then, you just differentiate that function, so it would be e to the x squared times 2x. That's basically what the chain rule is. Easy. Now, I have to go over higher order derivatives. It's easy, just find the derivative of the derivative. But what's the second derivative even used for? Concavity. Smiley face is concave up and sad face is concave down. We can just forget about the other higher order derivatives. Now, you've mastered derivatives. It's so useful you can use it in many jobs like